Welcome to our acids and bases video. In this video, we will talk about pH and how to measure it with a pH meter. So first off, we have to talk about what pH even is. So pH is the measure of free hydrogen ions in a solution. Since its range is so vast, the scale is logarithmic. Here, we are doing a 2-point calibration on our pH meter. We are doing this using a pH buffer of 7 and a pH buffer of 4. Make sure that in between each measurement, you rinse off the tip of the pH meter with distilled water. After the meter is calibrated, put the meter back in the pH buffers. To make sure that it is correctly calibrated, you should read pH of 7 on the first buffer solution and a pH of 4 on the second buffer solution. Now that I've mentioned a pH buffer solution, we have to talk about what a pH buffer is. A pH buffer is a solution that resists change in its pH. It is made up of a weak acid and its conjugate base. We have to talk about how it works. When an acid or base is added to the buffer solution, the conjugate acid or base binds to it, making the pH change less extreme. We can start measuring basic household solutions. In this first clip, we are measuring normal tap water. In this second clip, we are measuring distilled water. Both are slightly acidic solutions. Now that I've mentioned a slightly acidic solution, we have to talk about the difference between a strong and a weak acid. A strong acid fully dissociates in a solute, such as water, and a weak acid only partially dissociates, creating an equilibrium in the solution. Now we are measuring the pH of orange juice. That comes out to around 3.4 on the pH scale. Now we are measuring the pH of apple juice. It's going to be slightly acidic, around 3.4 on the pH scale. Stronger acid will have a lower number, and a stronger base will have a higher number. A weak acid will have a number just a tad below 7, and a weak base just above 7. Now we are measuring sodium hydroxide, a highly basic solution. We are getting a number really close to 14, about 13.3. Now we are measuring acetic acid, a known weak acid. We're getting a pH at around 2.5. Now we are measuring hydrochloric acid, a known strong acid. We're getting a very low pH, below 1. The final pH of hydrochloric acid comes to around 0.5. Wow, that's very low. Don't forget to put your pH meter back in the proper manner. This is our final table of the values we got for each solution. Thank you so much for watching.